All right. So I guess before we start talking about math, we should go over the things for the co-class. I do think some of you are new faces to me. Not all of you were in Co-16C last quarter, right? At least there's some people who I had last quarter who I've never actually seen their face because they came on Zoom all the time, which is totally fine. But I don't think that's the case for everybody. So we'll go through the details of the class. It's not that hard. And then we'll talk about verifying solutions to differential equations. Let me start by actually introducing myself. My name is James. My last name is Parmenter. You're welcome to just call me James. You can call me Mr. Parmenter or teacher or something else if that's convenient for you. I don't really care. I like James the best. I think it's a great name. It's been my name my whole life. I really like it. I was named after Jimmy, but I've always been a James. So, you know, sometimes things change. Let me learn. I'll try to learn your names. What's your name? Kevin. Kevin? Say that one more time. Ishan? Ishal. Okay. I'll go get it. And your name? Tessa? Alexandra? Flora? Heather. Cool. I will maybe know some of them next week. And then I saw someone online as well. We have Yesenia. Right on. Cool. I guess we should. So we'll go through the syllabus real quick. Here's the real kind of the short version. If you're actually enrolled in the course, meaning you signed up on Schedule Builder for 1 unit, you don't need to. Nobody needs to do that. Okay, and so I can definitely give you the CRN if you want it. But so here's the thing: you don't have to sign up for the class. You're welcome to be here, having just been added to Canvas, or not even being added to Canvas. Although I think there's no reason to not be added to Canvas because that's just where you're going to find any useful information. So if you're here, you should definitely get added to Canvas or sign up for the class with the CRN. Here's the difference, really. If you actually sign up for the class with the CRN, then you have to do the things to pass the class. The things you have to do to pass the class are fill the attendance form every time you attend. I would also like those of you who are not actually enrolled to also do that because attendance is important. We keep track of attendance. We keep track of the students we serve. It's part of the data that we use to justify being funded. And I like to think we provide good services. So we'd like to keep doing that. And the other thing you have to do is you have to do the weekly reflections. And I should note that they are time sensitive in that you can't make them up later. So if you're actually enrolled in the class, you need to do those 2 things. If you're not enrolled in the class, but are just on campus, I would also like it if you did those things, but it's not absolutely required. That's kind of the short version of the syllabus. That's the important thing. Everything else is superfluous.
For the unit, does it show up on our transcripts or is it just for the minimum?
You know, that's an excellent question. I don't know if it actually shows up on your transcript. I do know that it does count towards making minimum progress, but you're right. It is a workload unit, meaning it doesn't count towards the unit cap towards graduation. It doesn't meet that requirement as well. So I don't think it does, but I'll clarify and get back to them because I don't know. I actually don't know the answer to that question. I feel like it does, but I'm not 100% positive. Okay, let's go ahead and take a look at the Canvas. And I wish this screen, it turned on for like a second and then it turned off. And let me try turning it on again because I would prefer not to be looking up there the whole time, but that's usually what I end up doing. Yeah, I don't see any light going on. So you see, I think I might have like somehow done something stupid when I was doing it. Oh well, it's not worth dealing with right now. I can look up there. It's fine. Let's go ahead and grab the Canvas, which I hid from myself somewhere. There we go. Dashboard. I know you can't see it just yet. Give me a moment. There we go. Oh, there we go. All right. So over here is the Co-16 class. Oh, by the way, just in case you didn't know this already, you can on your own Canvas change the name of something. So I often, when I write the name of something, I like to write down like the time it's at. I think it actually somehow, yeah, Monday, Wednesday, Friday at 1 is what I changed that to. So it's helpful for me. Something that I also put the CRN there just because I often have to refer to it for other people. So I'm like, oh yeah, the CRN is this. So by the way, if you want to actually enroll in the class, the CRN is 56598. The homepage right now is the syllabus. I'm going to change that probably by the end of the week so that the homepage will be the modules because the modules are where you actually find anything you might want really in this class. In the modules, there are some useful links, like the link to the class attendance form, which we'll talk about in a second, the link to the class Zoom, Grant's website, which I refer to often. Grant is one of the other specialists. He's got lots of useful information. If you took 16A and 16B, you might have already seen it. And then there's also Kuba's 16C website. He's a former professor at UC Davis. He has lots of useful material. So if you're looking for extra problems to do or practice tests, those are two great places to look. And there's my website, which is not great. It's like there's some moderately useful information there, but it's not the place you should go to find useful stuff. But there is a picture of me and my cat. So if you want to see my cat, you can look at that. And then the YouTube playlist where we're going to play. So all the videos from class I will post both on Canvas and they're posted on YouTube, but they're linked from Canvas. So you can find them on YouTube, you can find them on Canvas. It's probably easiest on Canvas, but do whatever you like. They'll be there, as well as the notes from class that I write that you'll see here eventually. Yeah. And then often I usually will post here as well, practice exams or other useful material. Basically anything that's worth finding on my Canvas is in the modules. What else to say about Canvas? You can also find the Zoom link here under the thing that says Zoom. I believe you can click on that and then click on like the class meeting for today. I feel like if you clicked on any of these, that would probably take you to the right place, to be perfectly frank. And then we have the syllabus, which we should go over, even though it always feels a little bit tedious. So let's see, let's do this quick. Of course, if you have questions, you should ask them. I'm happy to ask questions. I'm happy to slow it down. I just find this part tedious because like I've done it many, many times. But let's go through it. So I would love to see everybody in person, but you can always come on Zoom. You can also watch the video later, which we'll talk about in a minute. How can you get a hold of me? Email is best. You could try calling my office phone. If I'm there, I will pick it up. My office is in 2244 Dutton Hall. I also have office hours. They are at these times in these places. Just for clarification, CADS is the Center for African Diaspora Student Success. It's over in the South Silo. And C-Class is the Center for Chicano Latinx Academic Student Success. And that's over in the Memorial Union. Anyone is welcome in both those places. You're welcome to come find me there if you're looking for help with that. There's also other specialists like myself, like Grant and Sarah, and why am I blanking on the person I'm thinking of? Duff, Casey, other people who help with math. If you're looking to find one of them, you can go to our website, the AATC website, which is tutoring.ucdavis.edu, and scroll down a bit. Somewhere here, you scroll down a little bit, keep going, keep going. There's all the classes. If you go a little bit further, you'll find the specialist office hours. Claire's on Zoom. Grant is all over the place, like myself. Sarah is a little bit less available. And I'm surprised to see Jen usually has office hours, but I'm guessing she has less office hours this quarter, or maybe they're only for the students in the class she's teaching because she might be really busy. So, but there's where you can find the specialists. There's also student tutors in the, again, I'm kind of making some assumptions about you're in 16C, you probably took 16A and or B here. You might be aware of some of the resources already, but in case you didn't know, the lower level of the library, where Math Drop-In is where you can find some student tutors, and myself sometimes, and Grant sometimes. We are there to help you with math in all sorts of places. Got off track a little bit there, but that's all right. So you can find me in office hours. And as far as grading, I kind of talked about it already. The way you pass the class is by filling out the attendance form and doing the weekly reflections. The weekly reflections are not hard. Let me show you. They're really kind of basic. I'm usually, so the first week's maybe an exception. We'll click on this one and on the next one. So the first reflection, I'm just asking you like, what's your name? Where are you from? Maybe something interesting, maybe a joke. You don't have to tell me a joke. I just like jokes. Usually some sort of not mathy important question just to kind of, to get to know you a little bit better. Since I do a lot of the talking and you do not, this is kind of the way, and I usually I will read all of these. Sometimes I respond and be like, oh, tell me more about this. But mostly I just like, oh, this is kind of neat. And then usually in the reflections after that, I ask you what you did in your actual class. And then if there's anything you want to see me talk about in the upcoming week. This reflection, you might note, is available from April 5th, is due on April 6th, but is available until April 11th. So I'd like you to do them like right at the end of the week, but you have until like the Thursday of the next week to actually finish it. But once it's closed, it is actually closed and it does not open back up. So if you're actually enrolled in the class and need to pass it, you need to do the reflections in a timely manner. And that's, yeah, because they're kind of meant to be done like, so I know what you're doing this week, not like 3 weeks from now telling you what you were doing 3 weeks ago. Yeah. And what's your name? Emery. Nice to meet you. I would love for everyone to do everything, yes. But you don't have to if you're not actually enrolled for the unit. But yes, please do them if you have the time. You can see it's not a lot, right? It's a few questions. And I think in the free, like the first one's like, what did you cover in your class? Your answer can be brief, a few bullet points, a couple sentences at most, right? I don't want a paragraph. I just want to be like, we learned about solving differential equations or first order linear differential equations or whatever you're doing, like just kind of, and maybe something was really confusing you, like we did this. And also I'm curious about this particular aspect. That's kind of what I'm looking for here, just so I can get a sense of how you all are feeling about the class, what might have been hard, what might have been easy, so that I can kind of modulate what I'm doing and adjust so that you are getting the best help you can. And then sometimes I'll ask you something silly like, what did you learn last quarter? Or do you like red vines or Twizzlers or whatever? Like, I'm just trying to keep it as fun as I can make it. Let's see here. And then the other thing is the attendance, which that's not the thing I'm looking for. Where'd you go? I think I go back to the syllabus. The weekly reflections, and then here's the form for the attendance, which you can see right here. It's not too hard to fill out. You're going to write your email there. There's mine, your ID number, your name as it appears in Canvas. So I would write my name as James Parmenter. Please do write your first and your last name. It makes it easier for me to fill out the attendance stuff later. What class are you attending? That would be this one. How did you attend? Live in person or live virtually like Yesenia, or you watch the recording later, which we'll talk about again in a second. And then finally, what date are you attending for? So I would fill in the date as whatever today's date is, which is, can I fill it in here? I'm sure I can. I just have to start typing some numbers, right? 04, 01. And please do enter the correct year, because sometimes stuff gets all over the place. Students enter like year 0 or year 2000, or please enter the year 2024, all 4 digits, not just the first 2. And then what I'll say here is I would love everyone to attend live in person, but sometimes you can't make the class, or you might not be feeling well and you shouldn't make it to class, or you have other classes that are more important than this class. This should probably be the least important class you're taking. It might be the most helpful class you're taking. It's definitely the least important class you're taking. If you need to miss this class, miss it. If you have a test right after this and you don't feel like this is going to be good for you to take that other test, don't come. But if you need to make up the attendance because you need to pass the class, because you need to attend, you can make up the attendance by watching the recording later and then filling out the attendance form. And when you fill out the attendance form, please fill it out for the date of the class you missed. So like if you missed today's class and you watched it on Friday, still write today's date, April 1st, 2020. Make sense? Okay. And then, as you might note in bold there, I would like you to make up, not would like, I should be worse for, I require you to make up attendance within 2 weeks of the missed class. So one, like if it's April 17th, this class, you can't make it. So, and I think that seems reasonable, right? We're trying, like the material is occurring in a sequential sort of way. 2 weeks from now, yes, it might still be pertinent, but like we need to see the material in the time. So if you miss a class and need or want to make up the attendance, please do so within 2 weeks. And importantly, make it up and then fill out the attendance form, right? If you don't fill out the form, I don't know that. So like all of you right now, I would love for you to be able to see what I'm putting out there. For you to scan this QR code I would encourage you wow, my goodness. So sure, scan it, try it now. Yeah. Where'd you go? It's hiding. Sometimes I do stupid things. Where did you go? Oh, it's over here. Ha ha ha. It's hiding from me and from you. So I would encourage you to bookmark the page that this is on so that you don't have to keep scanning this thing every time you need to fill out the attendance form. And yeah, fill it out every time you come to class or watch the video later or whatever. Try to fill it out just once per class. Sometimes people do like, oh, did I actually fill it out? And then fill it again. Try to remember, like, I actually filled it out. It's not a huge deal. I then like try to delete like the duplicate attendance forms. So yeah, attendance. Questions about attendance? You make sure you do it. So what'll happen with the attendance is it'll appear in a Google Sheet for me, and then I will go look at that Google Sheet and put fill out the attendance roll call thing on Canvas so that you can see that your attendance has been recorded. Question? The date of the video. Right. So for today's class, even if you watch it 3 days from now, you would still put today's April 1st date. Right. Let's see. What else do we need? What else is on this syllabus here that we need to see?
On Canvas.
Yes.
Fill out the attendance form within a week of the date.
Yeah, I meant to change. I meant that's something that I need to change.
Okay.
Yeah, 2 weeks.
Okay.
Yeah. I mean, a week would be better. 2 weeks is totally what I mean. And I thought actually, so I'm glad you caught that. Thank you. All right, let's minimize this. Where's my cursor?
So it says 2 weeks if you're absent, but then 1 week.
Sure. I'll change it all to 2. I'll change it all to 2 weeks. Ideally, you do it as soon as you can.
Yeah.
But the cutoff is actually 2 weeks. And I will definitely make note of that and change it when I have a moment. Let's go back to the syllabus if I will probably see that right now. Yeah, right there. I see what you're saying. Must fill out the form within a week of the date. Right. I'll change that to 2 weeks because that is what I actually mean. Right. If you're absent, right, and there it says 2 weeks down there. Yeah, those should match. Also, not passing this class is not that big a deal. Everyone should be able to pass though. So like, please do the things you need to. I would love to pass everybody who needs to pass. Occasionally someone doesn't do the things they need to do and they don't pass the class. I'm like, you could have done the things. So please do the things. They're not hard, but they do require actual doing. Let's see about this class. If something outside of this class or inside of this class, I guess, is impacting your success, please don't hesitate to talk with me about it. I want to be a resource for you. If that something is me, you should let me know, or if that's uncomfortable, you should let my supervisor know. I think I'm a generally fairly friendly guy who's easy to approach, but that's myself thinking about me. Maybe you don't find me that way. So anyway, my boss is lovely. She will gladly tell me anything I need to be told if you feel like I'm doing something that seems stupid. Again, I don't think it'll be the case, but who knows? We all have our own personal biases that we might not be aware of. So I will try my best. Let's see what else. There's also a form you can fill out, I guess. Yeah, I'm saying this like I don't know it. I've actually seen this form before. There is a form you can fill out. There are also the Academic Retention Initiative Centers are excellent resources for support. So there's lots of places to get help, to give feedback. Again, this class is pretty easy wheeling. I'm going to do my best to help you all get through 16C. Probably your last math class at UC Davis, I would guess, for many of you, most of you. I assume some of you probably still have to take stats afterwards at some point because that's usually a thing. And just so you're all aware, you may or may not know, this is not the last quarter the 16C is offered, but I believe either next fall or next winter is the last quarter that 16C is offered. So I imagine that's not going to be an issue for any of you because you're all going to pass and won't be a problem. But just so you're aware, that deadline is coming up on the horizon. And then this last part here, last parts-ish. The class is now in this place. You're all here. Great. The class period is going to consist of me showing examples, maybe having you work on some examples, maybe with each other, maybe on your own. Come to class prepared to write things down. I mean, I am of the opinion, as I think many people are, that learning math really happens through the end of a writing utensil. You have to write things down to really kind of get a sense of what you're doing and to practice it. Just looking at the math is not going to be the way to really learn it. So I'm going to do my best. And unfortunately, because of the hybrid environment that I'm trying to have, it makes it more difficult for me to give you as much time to do things on your own, because I feel like the people watching the video later might not appreciate that as much. So I try to find a balance, but I'm definitely going to try to have you all work on problems on your own and with each other, because again, that's how I think you're really important things. Accommodations, if there's something I can do to improve your ability to succeed in this class, please let me know. You can let me know through Canvas or other ways. If you have formal accommodations at the Student Disability Center, please let me know as soon as possible so we can make sure that you are getting what you need. For this class, the accommodations, I'm always happy to accommodate for them, but not most, but certainly a large amount of accommodations are testing accommodations, and there aren't any tests in this class, so that part is not really useful, or doesn't really make a difference. But if there are other accommodations, and I've read through the ones I have, I'm certainly happy to do that. Classes are recorded, notes are provided. If you're a person who wants to make your own recording, that's also totally fine, although I don't think particularly necessary. But really kind of do whatever you want and or need to do. It's fine with me. We're all familiar with the Zoom instructions. So notes out the class. Yeah, I should just delete this part here. I've always tried to get people to use the discussion tab in Canvas, because like you can ask a question and I can write a response back, or a fellow student write or something. And it's really great because there I can type math really nicely, because they have this way of doing it. It's excellent. But nobody ever does it. So maybe you all be the first to use the discussion tab in Canvas. It's right over here in the discussions. I click on it, maybe. All right, let's see, you could like, oh yeah, and there's that there, which I may or may not actually need to post. So I haven't posted it yet. Back to the syllabus. I think that's most of it. Scroll down just to see. Yeah, I mean, just the third quarter, your students, it takes time to learn this stuff. This says successful students usually spend 10 to 20 hours per week doing homework. Burke is going to give you a decent amount of homework. She expects you to work, which is why her name rhymes with work. Yeah.
She gave us 3 options to choose for like what your grade is in on.
Okay. I have, but I forgot that was a thing she did. When do you have to decide by? Tonight.
Oh no, that's it's week 4.
Okay.
Yeah.
All right, let's take a look. You know, I'm on her campus. Let's see here. So if we go over to the actual 16C canvas.
Yeah.
So where would I find this? So
No modules.
okay, let's go to modules.
Syllabus.
Welcome in syllabus.
Page syllabus.
Ah, thank you. In surveys at the end of week 4 and week 9, you'll have an opportunity to make a choice for your grading scheme in this class. If you do not make a choice, you will default to option 1. Okay, so I would choose the option where homework was weighted as highly as possible without even looking at any of it. I know I'm going to do all the homework and I'm going to probably kick butt at it. So that's what I'm choosing. So I'm definitely not picking option 3 if I'm a student, just right off the bat. Class engage. So again, I would probably pick option 1 because I know that I can get the class engagement points by doing the things I need to do. And then by doing the homework, and then the tests are weighted as little as possible. And that feels the least stressful to me. So that's what I know for myself. I would pick. That doesn't mean that you are the same as me. You might not want to do all the homework. Maybe you've taken this class before and you're like, I know the things, I just didn't do the things. I still wouldn't, no, I can't recommend option 3. Everyone should do all the homework. You should do all the homework. Let me say it again. You should do all the homework. I'm going to say a lot of times you should do all the homework because that's how you're going to learn the math. Like I can't say it any more ways. You learn math by doing math. At least that's how I learn math, and that's how I've known other people. I don't know of another way of actually learning math other than just doing it until it sticks. Maybe that's not actually, no, that's I can't even lie to myself about it. That's how I feel. Like, and maybe you are different, maybe other people are different and they learn math different ways by just seeing it. I can't imagine that's true. So do the homework is what I'm trying to say in case that wasn't clear. Does that answer your question though, as far as like what the options are? And yeah. So I would pick option 1 or maybe 2 if I didn't feel like doing the class engagement things and thought the final I was going to rock on, but I couldn't pick option 3. I just wouldn't feel good about that. Yeah, but maybe you really don't want to do the homework, which I couldn't even recommend. Yes, Yesenia, the CRN, in case you didn't see it. Where's my, that's the only thing I don't like about this. My cursor ends up over there, and now it's like gone. There's my cursor. The CRN, what is the CRN? It's not up here. Sorry, it's over here. The CRN is 56598. All right, I think that's all the things I wanted to say as far, and it always takes longer than I wanted to. Because now we only have like 22 minutes to talk about math. But before we talk about math things, are there any other things you would like to clarify, answer?
Do you have any recommendations for like if you haven't taken 16A or B, you haven't done that in a while? In terms of getting some.
Yeah, I would say so. The things I would say you need to be the best at right now to be successful in 16C are to be able to differentiate things and anti-differentiate things with relative ease and confidence. Yeah, specifically, so you should know the derivative rules for, in fact, and I will maybe find a list of, I have a list of them somewhere that I can post so that you can be aware of them. Oh yeah, there's that. And then for anti-differentiation, I'd say you specifically need to be aware of the method of U substitution and integration by parts. Not that there aren't other methods, but just top of my head, those are the things that are going to come up the most often, at least right away. Yeah.
Are limits very important?
I mean, for this course, let's see, limits very important. They're definitely very important. Do they come up a lot in this class? I don't. Oh, and there is one part where we do, I think. Sorry, I always forget the course material. You know what? Let's do ourselves a favor. Let me show you something else interesting or useful, maybe. Maybe. Yeah. Let's go ahead. So, but one thing you can look at is if you go to the Math Part website. That's not super useful for you because it's probably the last quarter you're taking math class, but still, you go over to courses and go to syllabi. And then over here, we'll show you what you're actually supposed to like learn in class. Let's see, you've got differential equations, you've got 3D coordinates. It could come up right here in functions of several variables. Sometimes you do limits of a multivariable function, but no, as far as I can tell, sequences and series is where it will probably come up if it's going to come up. Oh, use method, never do that. Okay, so yeah, so probably not a whole lot, but they could. All right, other things. You can come and go as you please. I am right. You don't have to ask me to use the restroom or to leave early or show up late. I prefer you don't show up late just because. No, I don't. I really don't care. Like, I mean, I care, but like, I don't care as far as like you should do what you need to do. So yeah, if you need to leave early to get to a class that's in anywhere across campus, feel free.
On the homepage for Math 16C, she posts a review. There's all the rules.
Cool, great. So, and that's on the
homepage for.
Got so many pages up now. Sorry, it's always weird working with 2 screens here. But yeah, I want you over there though. keeps wanting to come back over here. So we go back to like her homepage.
Yeah.
And said there's brief review. Cool. Right. So yeah, limit rules. Okay. I feel like it's not, I would not focus on that. I would focus on these derivative rules, which again are given very generally. And then, yeah, you should know the trig derivatives. And I feel like this list is missing a couple things here, in my opinion. There's a few other derivatives we should know about that I will definitely, I'll find something to post. Because there's like the exponential function, the logarithmic function, you should also, you should know all the derivatives, essentially what we know. Then integrals, usual rules. Yeah. You said, yep, okay. I feel like we're on the same page, which is not surprising because I like Karana a lot. She's great. Or Dr. Berg. First name's Karana. All right, let's do a few examples before we run out of time here. Unless there's other questions. I want to show you some examples because okay, cool. This thing is making some real noises over here. Okay. Oh yeah, good. Thank you. You should, yes. As far as seeing things up here goes, please always let me know. Occasionally I go too far high or too far low, or just my writing is trash. Just let me know. I'll try to make it better. Like here, I'm way down. There we go. Let's move that cursor out of the way. Great. I would like this to be closer to me, so it's always hard. Down here, let's move this down. Great. Right. It's like Co-16C. Today is April 1st, 2024. It's pen, not my favorite. So differential equations. These pens. Having you grab a new pen, not ready to write. Differential equations. So a differential equation is just an equation that involves a function and one or more of its derivatives. So let me give you some examples. Y prime equal to 3 times y. Or if you prefer, and we will definitely go back and forth between the prime notation and the Leibniz notation, you might write this as dy dx equal to 3 times y. There's your derivative, there's your function. Or maybe something like f double prime of x plus 4 times f prime of x plus f of x equal to 0. That's also a differential equation because you got a function and one or more of its derivatives. You got a first derivative and second derivative there. And you can kind of go on, right? You could have something like x times y prime plus 2y equal to x times cosine of x. You don't even actually have to have the original function. For example, something like y prime equal to x squared, that's also a differential equation. In fact, you know the solution to this one. If the derivative of a function is equal to x squared, then we know the solution is going to be that the original function is the antiderivative of x squared, which is x cubed over 3 plus c.
How to add to these a differentiable function and one of its derivatives? Where's the differential?
Well, you're right. That's what we usually say, but technically you don't actually have to have the function itself in the thing. But usually we do. But technically this is a differential equation as well because there's the derivative of the function itself. I know it feels kind of like sketchy a little bit, but this is totally a differential equation that we run into all the time. In fact, you ran into a lot of these in 16b where you said, oh yeah, the derivative of something is equal to like x squared. And I solved that by finding the antiderivative. Oh yeah, the original function is x cubed over 3 plus any constant. I want to emphasize here that when you're solving a differential equation, this is the solution. So whatever the function is itself, that is the solution to the differential equation. So let's look at some examples. Yeah. Again, if something gets off screen, let me know. Or if you need to go back, it's totally fine. So let's start off by not finding solutions, but showing things are solutions. So we're going to show that y equal to x to the fourth plus 2 is a solution to the differential equation, which we often abbreviate as diff EQ, or sometimes just DE. For y minus x times y prime equal to 8. I'm not in love with this pen. Got a new pen thinking it was going to be awesome, and it's feeling less than awesome. So there's a couple ways to approach this kind of problem when you're asked to show something is a solution. My usual bent is to look at what I've got in this differential equation and say, okay, I've got a y and a y prime. If they tell me that my solution is y equal to something, then I'm just going to use that. Sometimes you have a solution that's a little bit more implicitly defined, which is better. But if you have y equals some function of x, whatever your variable happens to be, you can take that y, find whatever derivatives you need, plug all that in, and see if the things work out the way they're supposed to. So we know that y is equal to x to the fourth plus 2, and y prime, the derivative of that's going to be 4x cubed plus 0. And then what we're going to do is we're just going to substitute these things in where they occur in this equation. So I'm going to rewrite this now as 4 times x to the fourth plus 2 minus x times 4x cubed. And personally, I don't like to say that it's equal to 8 yet, because I'm trying to show it's equal to 8. So I'm just going to do the work. So I'm going to say that's equal to 4x to the fourth plus 8 minus x times 4x cubed is 4x to the fourth. Those 4x to the fourth end up adding up to 0. I'm left with just 8. And that works. The thing on the left is equal to the thing on the right. Great. So that's how I would approach something like this. They can be a little bit more complicated, though. Let's look. Sorry. Let me know. We ended at 2, right? Yeah, we ended at 2. Not that you're not, well, if you need to go, you need to go. But the time here is like 15 minutes slower than the time there, which is annoying. And I don't think there's a way to fix it here, which is also annoying. So if I get close to going over, please let me know. I don't intend to, but I might be looking at the timer and be like, oh yeah, it's 1:36, not 1:50. So let's look at another example. And if you need to go, you're good to go. Let's say we want to show. In fact, I want you all, to show that f of x equal to 3e to the x squared is a solution to f prime of x equal to 2x times f of x. So here's what I want you all to do. Find f prime of x, and then find 2x times f of x. Or as I think Burke might be writing it, I think she's saying, right, the left-hand side and the right-hand side. So I want everybody to find the derivative of 3e to the x squared. I remind you of the chain rule. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. Right, constant I like to say constant multiples hang out. So the derivative of 3 times some stuff is 3 times the derivative of that stuff. So when we take the derivative of 3e to the x squared, we're gonna get 3 times the derivative of e to the x squared, which is gonna be e to the x squared times the derivative of x squared. Right.
What is, sorry, what is f times x equals 2x?
Times f of x. That's a times, yeah. The right-hand side, 2x times f of x is equal to 2x times 3 e to the x squared. And do those look the same? I think they do. I mean, they're not literally exactly written the same way, but I think we can tell that 3 times e to the x squared times 2x is the same as 2x times 3 times e to the x squared. So the right-hand side is equal to the left-hand side.
I like that, left-hand side, right-hand side.
That's fine. It's not always applicable depending on how you're doing things, but it's totally fine.
Sometimes I find it's hard to organize when I'm finding the derivative of the thing, and then you also.
Right. Like for me, honestly, if I was doing it kind of more how I would choose to do it, I would do this. I would say f prime of x is equal to 3 e to the x squared times 2x, which then I would choose to write as 2x times 3 e to the x squared, and then observe that's equal to 2x times f of x. Be like, cool, I did it. F prime of x is equal to 2x times f of x. That's how I would choose to see it.
So that's for expression for logs, is it the same thing?
So I would say it's the same thing for every kind of function. Meaning, if you have your function of some stuff. So in fact, this is probably a good time to take a few minutes to talk about the chain rule. So when I think of a function of some stuff, here's the kind of function I'm thinking of. The functions we have that we need to be able to differentiate are something like f of x equal to sine of some stuff, or I'm just going to write a bunch of f of x's here, cosine of some stuff, or tangent of some stuff. I don't know why I changed to g of x there. I just happened to. Or f of x equal to cosecant of something, or f of x equal to secant of something, or f of x equal to cotangent of something. And we also have f of x equal to e to the something, or f of x equal to the natural log of something. This list is not quite exhaustive, but it's most of the functions you need to be aware of how to differentiate. And so what I would say is, whenever your function is one of these functions of some stuff, where the stuff is a function of x, the derivative is going to work like this. For example, if f of x is equal to, say, sine of x cubed plus 2x, well, I know, and you know, that the derivative of sine of x is cosine of x. So the only thing that changes now is that the derivative of sine of some stuff is going to be cosine of that stuff. And then what do we have to multiply by? The derivative of the stuff. That is always the answer when we talk about the chain rule. We are always at the end multiplying by the derivative of the stuff. Cool. So if your function is, say, the natural log of x to the fourth plus tangent of x, then the derivative, well, the derivative of the natural log of x is 1 over x. So the derivative of the natural log of some stuff is going to be 1 over the stuff. And then just like last time, we have to multiply by the derivative of the stuff, which is 4x cubed plus secant squared x. All logs, but if your base is different, then we have an additional thing to look for. So that brings up a good point. So yeah, we got time. We got 4 minutes.
Sorry, I just.
No, you're good to go. So a couple other things. So the derivative of e to the x is e to the x. Kind of everyone's favorite sometimes because it doesn't change. The derivative of e to the stuff, like x squared plus 3x, is e to the stuff times the derivative of that stuff. But if you change your base, there's an additional thing to look out for. So if your base is something other than e, I will point out your base does need to be a positive number, can't be negative, can't be 0, and it also can't be 1. Because 1 to anything is just 1, so it's not. But say, for example, the derivative of, say, 4 to the x is similar. It's still the same kind of function. If you think about the graph of e to the x and the graph of 4 to the x, they look very much the same. They both have the usual exponential shape like this. And their derivatives are very similar, except you also have the natural log of the base. Now, I'll point out, I could have also written that up here, because the natural log of e is just 1. So really, the formulas are the same. We just don't write that part of it. And then over here, if you have the derivative of, say, 4 to the x squared plus 3x, you would get 4 to the x squared plus 3x times 2x plus 3. You're welcome. Times the natural log of 4. I'll say one thing is you're exiting. If it's a log with a different base, you end up dividing by the natural log of that base. So if I was going to take, for example, the derivative of log base 4 of x, instead of being just 1 over x, it'd be 1 over x natural log of 4. You're welcome. Bye. And so then, sorry, I gotta put that in the wrong spot. And then the derivative of regular natural log of x is just 1 over x. And then we have the chain rule versions. The derivative of the natural log of some stuff, like x squared plus 3x, is 1 over the stuff times the derivative of the stuff. And then we also have a 1 over natural, oh, nope. Sorry, that's for the next part. Lots of times people write this as 2x plus 3 over x squared plus 3x. I usually don't, because I really like to think of the multiplying by the derivative of the stuff at the end, because that's how I'm always saying it. And then if we had a different base, like log base 4 of x squared plus 3x, then we would get 1 over the stuff. There'd also be a natural log of 4 down there, and then we multiply by the derivative of the stuff. So when you have a logarithm or an exponential thing with a different base, you either divide or multiply by the natural log of the base. That's the only thing that really changes. This doesn't come up a whole lot, but it comes up. Exactly. Right, exactly. And here's what I'd say. Basically, every derivative you know how to take, there's always a chain rule version of it, right? Instead of saying you have something with x, you have something with some stuff. Instead of the natural log of x, you have the natural log of some stuff. And the rule is the same. The derivative of the natural log of x is 1 over x. The derivative of the natural log of some stuff is 1 over the stuff times the derivative of the stuff. So if you know the regular version of it, you know the chain rule version of it if you just say the words in your head. And it's 2 o'clock, so I should stop talking.